Okay, the last problem using the two equations. Here we're talking about meters, so I'm using the gravity of 9.8 meters per second. I need to replace everything in there to find the two equations as a function of time. So x is going to equal, the velocity is 40, cosine, the angle that it makes is 45 degrees t, and then the y equation. Be negative 4.9 t squared plus the velocity of 40 sine 45 t, and the initial height 300 on a cliff, 300 meters, so plus 300. So I plugged in both in the calculator. I got 28.28 t for x. The other one, negative 4.9 t squared plus 28.28 t plus 300. To figure out how long the ball is in the air, right, that's when I'm going to have to graph it and see where it crosses over here on the x-axis. So let's graph the y equation. Okay, so how long it's in the air, we need to graph the equation. So I just graphed it, and I'm looking to see where it crosses right over here. And I got my x to be about 11.2 seconds. Then that was part B. For part C, it asks, when is the ball at its maximum height? Determine the maximum height. Well, to determine the maximum height, we need to figure out right here. So we need to press second, calculate on the calculator, number 4 for maximum, do our left bound and our right bound, enter for guess, and I get the maximum to be in 2.9 seconds. It will reach its maximum height, and that height is 340.8 meters, the height of the ball, the height, max height. And that's the time it takes to get to that max height. That was part C. Determine the distance the ball traveled. Well, I need to use the equation that I developed from the beginning, which was that x equation. And what time do I need to plug in for the t? Well, that's when it hits the ground, the 11.2 seconds. So I need to replace in my x equals 28.28 t, replace the t with 11.2 seconds. And I get it to be 316.7 meters, the total distance the ball traveled. And then part C was the max height over here.